All right, now, senior, let's continue with our friction. A quick recap of what we did last time. Friction is the force which opposes the motion of one surface over another. Also, solid friction is the force which opposes the motion of one solid surface over another. Think of what happens when you rub your palms over one another. You experience some resistance of the motion, of the two palms over one another. That resistance that you experience, or that opposition to their free motion that you experience, is called friction. It happens between every two surfaces in contact, especially solids. It happens in liquids and gases too, but we are looking at solid friction here. Effects of friction in our everyday lives. Okay, these are some of the everyday occurrence that remind you of friction. The heating effect we observe when we rub two palms over one another. That's one. Another one is the sound our pen makes while writing on a paper or on the board. That's another one. That sound is due to friction. The sound of our palms and the soles of our sandals moving on the moving on the floor or on the ground. Every sound your sandal makes or your shoe makes as they squeeze or scratch the surfaces of the floor or ground is due to friction. Then friction helps us to stop our cars. The loud sound you hear when you step on your brake and it makes a loud sound at the wheels is due to friction. Then when washing clothes, shoes, walls, and floors, the scrubbing that enables the soap to wash off dead particles from the surfaces of those materials is also due to friction. If there was no friction, the scrubbing won't lead to the cleaning of those surfaces. Now, loss of solid friction. The following are some of the loss of solid friction we are required to know. First one is solid friction opposes motion, or you can simply say friction opposes motion. But because we are looking at solid friction here, that's why I'll be mentioning that once in a while. It's nothing special. Okay, friction opposes motion. 2. 1. Friction opposes motion. 2. Friction is independent of the area of surfaces in contact. You will see that in a while now. Friction is independent of the area of surfaces in contact. Let me explain this with a very simple concept. Let's say you have a big box. Sorry for that distraction. Excuse me. Excuse me. Let's say you have a big paper box, very big, and you try to push it on the floor. Let's say it's a big carton of maybe a big generator or freezer or refrigerator or some kind of big TV. Now, as you move the carton on the floor, you will notice that you will experience very little friction because it's not about weight. Friction is independent of the area of surfaces in contact. Although that big box or carton will, cover a large surface on the floor, but the friction you experience while trying to push it on the ground will be very small compared to when you have a battery, like a car battery now, that is many times heavier than that box. So the car battery will have a huge weight. So you will notice when you try to push that car battery, which has a small surface area covered on the floor, when you try to push it on the floor or on the ground, you will experience more friction while trying to push the battery than the friction you will experience when you try to push the carton. So it's not about surface area in contact. It's not actually about the surface area in contact. It's about the what? It's about the normal reaction or the weight between the two surfaces in contact. So that brings us to law 3. Friction depends on the normal reaction between the surfaces in contact. Number 4, static friction between two surfaces is greater than the kinetic friction between them. The static friction which is the friction you experience while trying to move an object that was stationary. When you try to move a stationary object, the friction you experience is called limiting or static friction. But when the object has been set in motion, when it starts moving, the friction reduces. The friction that you now experience between the two surfaces will be called kinetic or dynamic kinetic or what? Dynamic friction. So, or sliding friction. So, sliding friction or kinetic friction is normally less than the static or limiting friction which you experience when the object is pushed from rest. So, that's the fourth law of friction. Then lastly, solid friction depends on the nature of the surfaces in contact. So you will easily understand that if you put palm oil or groundnut oil on your palms, as you rub them over one another, this loud sound may not be as loud because the nature of the surface has changed. Right now, the surfaces are very rough. So you experience lots of friction when you try to slide them over one another. But when there's a grease or oil or some kind of lubricant between them, the friction decreases. So the roughness of this nature actually means roughness. The roughness of the surfaces in contact also affects the extent of, amount of friction experienced. Let's now go to coefficient of friction. When two surfaces are in contact, there is something that is used for measuring the frictional force. It is called the coefficient of friction. It's a constant between two surfaces. So let's assume in this example that a box is placed on a rough surface. This is a rough surface that is not moving. If you place this box on the rough surface, many forces are acting on the box. If you place the box on the rough surface and try to push it to the right, many forces, if you try to push it to the right like this, there will be many forces acting on the box. Number one, the weight of the box will act downwards like this due to gravity. Can you see what I'm showing you? Just like you are seated now, your weight acts downwards due to the force of gravity. This is the force of attraction with which the earth pulls you to itself. So the weight of the box acts downward. That's the first force. Now, because the box does not move into the ground, although its weight is pressing into the ground, the box doesn't actually move into the ground. The box does not go anywhere. That means, for that to happen, it means that the floor is balancing the weight of the box with an upward reaction. It means that the floor is balancing the weight of the box with an upward reaction so that the two of them now balance each other. That's how there's no motion. Can you see? So we call this balancing force. We call it normal reaction. We call it what? Normal reaction. It is the reaction of the floor on the box upwards. Okay. Now, if you try to push this box to the right with force P, you will experience some resistance, which is referred to as friction. Friction will act opposite to your push. You understand? As you push it forward, friction acts this way. If you push it this way, friction will act opposite your push. Now, what happens when you change the direction of your push? Let's say you now choose to push it this way. If you choose to push it this way with force P, frictional force will now start acting on it in this direction. Okay, let me bring that down. If you try to push it this way, let's say your P is now here, frictional force will turn, and you understand? Frictional force, like some kind of a demon affecting every motion between two surfaces. So frictional force will act opposite your push. Can you see that? Now, from our laws of friction, we learned that the frictional force is dependent on the normal reaction. the frictional force is what? Dependent on the normal reaction. We learned that the frictional force depends on the normal reaction. So that means frictional force F is dependent on R. So every proportionality that that is direct like this has a constant of proportionality between them. So F is equal to KR. That constant of proportionality is what is referred to as the coefficient of friction between the two surfaces. So if I want to find the coefficient of friction now, I will rearrange. Mu R will be equal to F, and mu, which is the coefficient of friction, will be equal to F over R. Is that taken? So this is, I think, the first formula you need to know in solid friction. Take note. Let's now take one or two examples. Let's not waste time and just take one or two examples before we go to our next video. Let's just take one or two examples. Okay, a box weighing, let's say a box weighing 20 kilogram is pushed. A box weighing 20 kilogram is pushed on a horizontal surface. Let's just form the questions together. A box weighing 20 kg is pushed on a horizontal surface with a force of, let's say, 15 newtons. Is pushed on a horizontal surface with a force of 15 newtons. Full stop. Okay. If the coefficient of friction between the two surfaces, that is the base of the box and the surface on which the box is being pushed. If the coefficient of friction between the two surfaces is 0.12, calculate. Okay, let's just keep it simple now, no calculation. Will the box move? Let me just keep it simple that way. Look at this question. A box weighing 20 kg, a box weighing 20 kilogram is pushed on a horizontal surface with a force of 15 newtons. If the coefficient of friction between the two surfaces is 0.12, will the box move? That's a very simple question. Excuse me. If the coefficient of friction between the two surfaces is 0.12, will the box move? That's a very simple question. Let's find out. Okay, first thing I need to do. Okay, we will be given, take G as 10 meter per second square. So that can help us change our mass to weight. First thing you need to consider is, let's say this is the box and this is the surface. The weight of the box is W. The weight of the box is what? W. W is mg, which is 20 kilogram times 10, which gives you what? 20 newton. Since the box is not moving downwards, that means there's an equal and upward reaction that balances its weight acting downwards, but the reaction acts upwards. There's an equal and upward reaction acting upwards, which is also 200 newton. You understand? So our normal reaction, this one, we call it, let me change this, we call it what? Normal reaction. So the normal reaction is what? R, and it is equal to 200 newtons. So it says that if I push this box with a force 15 newton, let me take this as the direction of push. Will the box move? If I push it with 15 newtons this way, there will be what? Frictional force acting this way. What tells me whether the box will move or not is whether this push overcomes the friction. That's all. If the push is less than the friction, the box will not move. If the push is equal to the friction, the box will just be about to move. You understand? But it won't move still. It will only be about to move. So what we now want to find out is whether this push is less than or greater than the what? The frictional force. This is our frictional force. We can write FR if we like, or simply write F. So let's go ahead and find our frictional force. How do we find frictional force? Frictional force, we said mu is equal to frictional force over normal reaction. Did we just find that now? Here, coefficient of friction is what? Frictional force over normal reaction. So that means cross multiplying our frictional force. Let me be putting FR so that you get used to it. So cross multiplying the frictional force between the two surfaces is the coefficient of friction times the normal reaction. Now we already know our normal reaction as what? 200 newtons. So the frictional force will be 0.12 times 200 newtons. So that's what? 12 times 2, 24. 24, 0, 24 newtons. So our frictional force is what? 24 newtons. Can you see that? The frictional force is 24 newtons. So what does this explain? The frictional force is 24 newtons. The frictional force is 24 newtons. And you are just pushing with 15 newtons. Definitely the box will not move. It's not going anywhere. Can you see the what's it called? Can you see the significance of frictional? You are pushing with 15 newtons and the frictional force is 24 newtons. So the box will not move because P, your pushing force, is less than the frictional force. So you are pushing it this way, but frictional force is acting this way on the same object. This one, 24 newton, FR. This one, P. P is what? P is what? 15 newton. You are trying to push it with 15 newtons. Definitely it will not move because 15 newtons cannot overcome 24 newtons. Is that clear? So it's not going anywhere. So what will our answer be? Our answer will be, let's put it this way. The push is less than the frictional force. The pushing force of the push is less than the frictional force. Therefore, the box will not move. So just note, all of our calculations in friction will be built on this basic foundation. All of our calculations in friction will be built on this simple concept. So we'll continue with more examples in the next video.